Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video of quantum mechanics. Okay. This problem has been selected from the book Quantum Mechanics Concepts and Applications by Nordine Zetteli. Okay, Nordine or Nordine Zetteli. Okay, whatever may be the exact pronunciation. Quantum Mechanics Concepts and Applications by Nordine Zetteli. We come to problem of the statement first. Okay, high energy photons, that is gamma rays, are scattered from electrons initially at rest. Assume the photons are back scattered. Okay, back scattered indicates 180 degree angle. Okay, 180 degree. Assume the photons are back scattered and their energies are much larger than the electrons' rest mass energy E, that is E is very greater than MEC square. Okay, where E is written as a subscript of M. Okay. Part A, calculate the wavelength shift. Part B, show that the energy of the scattered photons is half the rest mass energy of the electron regardless of the energy of the incident photons. Okay. Part C, calculate the electron's recoil kinetic energy if the energy of the incident photons is 150 million electron volt. Okay. Now we move to its solution. Dear students, if this video goes larger than 15 minutes, then it will not be able to be uploaded on our concerned channel, that is Quantum Mechanics by Rajput Abdul Wahid Bhatti. Okay, because this channel is at its initial stage, it does not accept uploading of videos larger than 15 minutes. Okay, so in this case, if video goes larger than 15 minutes, then this video will be uploaded on our main channel under title Physics Lectures by Rajput Abdul Wahid Bhatti, which has about 287 videos in it. Okay. Solution. The experimental findings of Arthur H. Compton reveal, we are talking about Compton effect. Okay, so this is Compton, Arthur H. Compton or Compton. The experimental findings of Arthur H. Compton reveal that the wavelength of the scattered X radiation increases than wavelength of the incident radiation by an amount delta lambda, okay, called the wavelength shift. While according to classical physics, the incident and scattered radiation should have the same wavelength. Okay, so dear students, here this is a deficiency in classical physics. Okay, which has been pointed out by during Compton effect, Compton experiment. Okay, this wavelength shift is in accordance with conservation of energy and linear momentum applied to the photon electron collisions. Okay. Emphasis is laid on the fact that wavelength of scattered radiation is greater than the wavelength of incident radiation. Okay, while classical physics says that wavelength should be same. Okay, so in other words, it is a deviation from usual laws of physics. That is why such irregularities gave rise to quantum mechanics. Okay. Yes, students. Now we are defining wavelength shift. Okay. Prior to this, we have said that this wavelength shift is in accordance with conservation of energy and linear momentum applied to the photon electron collisions. Now we are saying that this wavelength shift is given as, okay, that is to say it is being defined mathematically. Okay, delta lambda is equal to lambda dash minus lambda equal to Planck's constant h over rest mass me into speed of light c into 1 minus cos theta, where theta is the scattering angle. Okay, this is equal to 2 into lambda c, where c is written as a subscript of lambda into sine square theta by 2. Actually, dear students, this is a basic trigonometric formula, that 1 minus cos theta is equal to 2 sine square theta by 2. Okay, very basic formula of trigonometry. Okay, 2 lambda c sine square theta by 2, we give name equation number 1 to this expression. Okay, this is equation number 1, where lambda dash is the wavelength of scattered radiation, lambda is the wavelength of incident radiation, me is the electron rest mass, h is the Planck's constant, c is the speed of light in vacuum, theta is the scattering angle, and lambda c, where c is written as a subscript of lambda, which is equal to h over mec, is equal to 2.426 into 10 raised to the power minus 12 meter, is called the Compton wavelength of the electron. Okay, dear students, we can confirm this value. Okay, from where we can confirm this value? For this purpose, we have given a table at the end of this problem. First, we go to the last portion of this is the table. Okay, from this table, this c speed of light is applicable here. Okay, this is Planck's constant h, this is applicable. Okay, so we can confirm this value by putting here the value of Planck's constant, here putting the value of me. Okay, and then speed of light, that is 3 into 10 to power 2.998 into 10 raised to the power 8 meter per second. Okay, if we put our values of these three constants, then this lambda c, that is c stands for Compton, and we note that wavelength is denoted by lambda while frequency is denoted by nu. Okay, these are the usual notations. Okay, so Compton wavelength, that is lambda c, where c is written as a subscript of lambda, becomes equal to 2.426 into 10 raised to the power minus 12 meter. Okay, lambda c is called Compton wavelength of the electron. Now we come to solution of part A. Okay, since the photons backscatter means scattering angle reaches 180 degree, that, and we know that 180 is equal to pi. Okay, since the photons backscatter, put theta equal to pi in equation number 1, we get, what is equation number 1? Equation number 1 is this. Okay, in this value, in this equation, we will put theta equal to pi. When theta will be pi, then pi by 2 sine 90. Sine 90 is equal to 1. Okay, so this portion will become less significant. It will be treated as 1, and when it is treated as 1, so it becomes equal to this 2 lambda c. Okay, because sine 90 is equal to 1, cos 90 equal to 0. Okay, similarly cos 180 equal to minus 1, sine 180 equal to 0, and so on. Okay, for the time being we are not discussing trigonometry. Okay, since the photons backscatter, put theta equal to pi in equation number 1, we get delta lambda equal to lambda dash minus lambda equal to 2 lambda c sine square pi by 2. It will be treated as 1, so it becomes equal to this, because this is equal to 1 and 1 square is also 1. It becomes equal to 2 lambda c, and we have previously mentioned that lambda c's value is this 2.42, which we can confirm by putting these three constant values. Okay, so a simplification gives rise to del lambda equal to 4.852 into 10 raised to the power minus 12 meter. Okay, simply lambda c has been multiplied with 2. Okay, so it solution of part A has become equal to 4.852 into 10 raised to the power minus 12 meter. Now we come to part B. Now energy of incident photon is equal to E is equal to h nu is equal to hc over lambda. We give number 2 to this expression, equation number 2, and similarly energy of scattered photon is equal to E dash is equal to h nu dash is equal to hc over lambda dash. We give number 3, equation number 3 name to this expression. Okay, so this is equation number 2 and this is equation number 3. Now from equation number 1, after using theta equal to pi, lambda dash is equal to lambda plus 2, lambda c is equal to lambda plus 2. In place of lambda c, we have put its value h over mec. Okay, where it is given? It is given here. Okay, we have used this value in place of here, in place of yes, lambda dash is lambda plus 2, lambda c is lambda plus 2 into, in place of lambda c we have used this value. Okay, using in equation number 3, we will use this expression, that is value of lambda dash in equation number 3. What is equation number 3? Equation number 3 is that E dash is equal to hc over lambda dash. E dash is equal to hc over lambda dash. E dash equal to h nu dash equal to hc over lambda dash is equal to hc over, we have put the value of lambda dash. Okay, here what in the next step we have done, what we have done, HME. Yes, students, actually here we will take LCM MEC. Okay, so this MEC will be multiplied with this, it will become MEC lambda plus 2h, and this MEC, because this is in the lower part of the denominator, so it will be shifted to numerator. Okay, so it will become here MEHC square, HMEC square. Okay, this lower part of denominator has been shifted to upper part, that is numerator, and hence in the numerator it has become HMEC square over MEC lambda plus 2h. Okay, in the next step what we have done, we have divided a numerator as well as denominator by h. Okay, both sides, upper and lower, by h. Hence from upper side, from a numerator, h will be cancelled, while in the denominator h will become below this, that is MEC lambda over h plus 2. Okay, here h will be cancelled, Now, yes, this is MEC square divided by here H has been here MEC yes. What we have done, we in place of lambda we have used its value HC over E. Okay, from where? From equation number 2. This value has been taken from equation number 2. Equation number 2, this. Okay, lambda will be shifted in place of E, and E will be shifted at place of lambda, and hence lambda will become HC over E. 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 Okay, yes, no doubt. What we have done, we have simply replaced lambda by its value from equation number 2, and it has taken the shape this. Okay, plus this. In the next step, yes students, what we have done in the next, yes, this H is cancelled with this H. Okay, so in the numerator no change, MEC square is as usual as in the previous step, but in this here H has been cancelled. Okay, upper and lower H has been cancelled, and simply MEC square over E plus 2. Okay, now situation has become quite clear. From equation number 1, after using theta equal to pi, yes students, using equation number 3, in equation number 3, yes, I think perhaps this portion has been mistakenly once again copied below. Okay, so we see what is the at the last of this step. Actually this is a duplication of by mistake. Okay, here E dash has become equal to this portion divided by 2. Okay, this portion divided by 2. The okay, yes, to this extent it has been repeated, and now after that okay, MEC square plus over E plus 2, MEC, okay, yes, okay, up to this has been repeated mistakenly, no confusion. Okay, now we see that this is approximately equal to MEC square over 2. We have assumed this, we have neglected, we have ignored this factor. Why we have ignored this factor, dear students? Here within bracket it is written that because E is very greater than MEC square, it has been provided in this statement. Okay, so because these 3 dots indicate because. Okay, because E is very greater than MEC square. So when dear students, a numerator is very small and denominator is very large, then its result becomes negligible or close to 0, so small that it can be ignored, it can be neglected. Okay, so here we have ignored this portion because here this portion is much greater than this portion, and its result becomes so small that it can be neglected. Okay, so it becomes equal to MEC square over it becomes equal to MEC square MEC square by 2. Okay, this portion has been neglected, and we know that we have values of all these 3. Okay, this value is also is given in the table. Okay, table in this table, this is okay 0.511 million electron volt over C square. Okay, so when we will put this value, yes, C square will be cancelled with C square, and E dash will become equal to approximately equal to 0.2555 million electron volt. Okay, now part C, if E is equal to 150 million electron. This is given in the statement. Okay, for part C. Then electrons recoil kinetic energy equal to E minus E dash equal to 150 million electron volt minus 0.2555 million electron volt, which we have calculated in the previous part B, previous step part B. So their difference becomes equal to 149.7445 million electron volt. And this is the end of our video. Till next video, Allah Hafiz.